Double distribution, day 1. So far, we have been multiplying monomials to other polynomials like below. And just to remind you, a monomial has only one term, binomial 2, trinomial 3, etc. Okay? So all the problems that we did yesterday, we had a monomial, so one term touching a set of parentheses that we would have to distribute. But what we're going to be dealing with today is a binomial, so two terms, times another binomial, so times another two terms. Okay, so I'm going to put this up here because I want to show you what the most common mistake is, so please don't write this down. A lot of people think that all you would have to do is multiply the x times the x to get x squared, and then we would do 3 times 2, which ends up giving me a positive 6. But this is not right because it's missing something very important in the middle. And the easiest way for me to explain what's missing is with regular numbers. Okay, so let's just say that I followed the same thing that I did up here. Multiply the first two together and the last two together. So 1 times 3, if I multiply that, I've got 3. 2 times 4, that gives me a positive 8, and I end up with 11. But if we actually followed PEMDAS, you would see that the answer to this problem is not 11. I'm missing a lot of information because 1 plus 2 gives me 3, and 3 plus 4 gives me 7, and 3 times 7 is 21. So that's why this doesn't work. You can't just multiply the first numbers and the last numbers together and then add what you've got. It doesn't work like that. Here is how it works. What you are going to do is take the first number in your first set of parentheses, or the letter, and distribute it to the second set of parentheses. Then you're going to do the same thing with the second term in the first set of parentheses. Distribute it to the second. That's why I call this double distribution. You distribute the first term, then you distribute the second. And if you notice, now if I add up all these numbers, now I do have 21. So that's why this works. Whenever you have a binomial times a binomial, you are going to have to distribute or double distribute. So here's what this would look like. Okay, I've got an x right here in the front. I'm going to start with that. I am multiplying it to the other two terms in the other set of parentheses, not to the 3. So when I multiply x times x, I am multiplying two x's together, which is x squared. Then I've got to do the same thing to the other term. Well, 1x times a positive 2 gives me a positive 2x. Okay, so I distributed that first letter. Now I've got to do the same thing with the second term. So I've got a positive 3, so make sure you take that sign with it, and I'm multiplying it to the second set of parentheses. 3 times x gives me a positive 3x, and 3 times 2 gives me a positive 6. So now that we've done double distribution, if you notice, I have a pair of like terms in the middle. I have a couple of regular x's, 2x and 3x. So now I need to combine some like terms. The x squared would move down first. 2x plus 3x gives me positive 5x's. Remember, you do not change exponents when you combine like terms, so it's still just an x. And then I can bring down my plus 6. I don't have any more like terms, so I am finished. All right, let's try another one of those problems. Same idea on example number 2. So I've got two terms times two terms, a binomial times a binomial. What I do is I take the first term in the first set of parentheses and multiply it to both in the second, so I'm distributing it. So that means we would start off with a 5a times a 2a, which gives me 10a squared because I was multiplying two a's together. Then I do 5a times positive 4, which gives me a positive 20a. All right, so I distributed my first term in the parentheses. Now I'm going to do the same thing with the second term in the first set of parentheses. So 3 times 2a gives me a positive 6a, and 3 times positive 4 gives me a positive 12. Okay, so I distributed, and if you do this right, whenever you combine like terms, they should be the two terms that are in the middle right here. Okay, so I still have my 10a squared. It goes first because it's got the highest exponent. When I add 20 and 6, I get a positive 26a. Do not change the exponent. And I need to make sure that I put my constant at the end. Now, if you've heard of this before, you might have heard of it called FOIL. which stands for first, outside, inside, and last, and it's basically just telling you to do what I did with double distribution. The reason that I don't call this FOIL is because eventually we're going to have more than just two terms and two terms, and all of a sudden FOIL doesn't work anymore. But double distribution will. There's also another method that will always work for you, and it is called the box method. So if you are having a hard time seeing what I'm doing over here, you might be more interested in box method. And it's going to be up to you which method you prefer to use. Now what the box method is just a way for us to see this a little better. I've got 2 terms times 2 terms, so I'm going to make myself a 2 by 2 box. And what I'm going to do with my terms over here is write them on the side of my box. So the first set of parentheses has 5a plus 3. It doesn't actually matter which side you put it on, so I could have put it up on the top or on the side. But I want you to notice that I put the plus sign with the 3. So anytime that there's a symbol, it needs to stick with the number that it's right in front of. Then I've got my second set of parentheses over here. I've got 2a and plus 4, so the plus sign stays with the 4. And all this is just a better way for you to see this. Now, if you're looking, and this is kind of like the squares that you do in biology, I'm just looking at the 2 that are lined up. If I do 5a times 2a, well, it's a little easier for me to see that that's 10a squared. Okay? Ignoring this side, now I'm just doing this box, which is 2a times positive 3. Well, that's positive 6a. Okay? Then on the bottom box, I'm ignoring this one now. I'm doing 5a times 4, which gives me positive 20 a's, and it's easier for me to see that I should have an a on that one. And then at the end, 3 times 4 gives me a positive 12 for this box right here. And if I combine the like terms, 6a, excuse me, it froze, 6a and 20a combine to give me 26 a's. So I'm actually going to show you both of these methods, and tomorrow you're going to have an option on which video you want to watch. Do you want to watch the FOIL video or double distribution video, or would you rather do the box method? So it's up to you. Let's get some more practice. Okay, so for number 3, I'm going to show double distribution again, and then on number 4, I'm going to show you the box method again. Okay, so for number 3, I have a 2y in my first set of parentheses. I've got to multiply it to both in the second. So 2y times 4y gives me 8y squared because I'm multiplying 2 y's together. Then I do 2y times positive 5y to get positive 10y. All right, once it unfreezes, then we're going to distribute the second term. Make sure you realize that this isn't just 3, it's negative 3. So I'm doing negative 3 times positive 4y, which gives me a negative 12y. And my 2 constants at the end, negative 3 times positive 5 is negative 15. And like I said, if you did this right, your like terms should be in the middle. So I'm going to go ahead and separate these out so that I can see all the different terms. Okay, so I still have the 8y squared, it moves down. But the 10y and the negative 12y are like terms, so I'm going to combine them together. And remember, combining means adding, so you can always just add those numbers to get negative 2y's. Do not change the exponents when you combine like terms. I bring down the minus 15, and now I'm done. Okay. So if you have no problem seeing the double distribution, that's probably the method that you want to go on. If that tends to confuse you, like there's a lot of numbers and letters going on, so that makes sense that it would be a little bit hard to see sometimes, you can try the box method. So if there's 2 terms by 2 terms, that's how you know that you've got to make yourself a 2 by 2 box. Okay, so I've got 2 terms, and I can put it on the top or on the side, doesn't matter. I'm going to put x plus 3 on the top. Make sure that sign goes with that number. So then for the other one, I've got x minus 4. Okay, got to make sure that that negative sign stays with the number that it's right in front of. And this is just an easier way for me to do multiplication. Now I can see in this first box that I am multiplying x times x. Excuse me, this thing keeps freezing today. X times x gives me the x squared that goes in this first set. Then in this box, I've got 3 times x, which gives me a positive 3x. Now I'm on the next row. So if you need to, you can cover up that first part. Now what I'm doing is a negative 4 times 1x, which gives me negative 4x's. And finally, at the end right here, I've got negative 4 times 3 for this last box, which gives me negative 12. So if you're doing the box method, that's what this is called, make sure you realize that what you're doing is multiplying whenever you do the box part. Then, whenever you combine like terms, you are adding. I still have x squared as my highest exponent, but then for my regular x's, I've got 3x and negative 4x. So if I add those two numbers together, now I've got negative 1x's. And I still have that minus 12. Now, this is a perfect answer. However, remember, we're not going to write ones when they're not necessary. So the best answer, and this is what it would look like on your answer choices, is this. Instead of putting negative 1x, it's just negative x. Okay. So let's get practice with one more of those. I'm going to go ahead and show this one as double distribution again. Okay, so example 5. I see that I've got a c in the very, very front. That's what I'm going to distribute to my second set of parentheses. So 1c times 1c is c squared. Then 1c times negative 2 is a negative 2c. Okay. All right, distributed the first term. Now I'm doing the same thing with the negative 4. Make sure you take that negative sign with it. A negative 4 times a positive 1c is a negative 4c. And then finally, I'm multiplying negative 4 times negative 12, which gives me, or negative 2, excuse me, gives me a positive 8. Okay, so now that I've got it like this, I'm going to go ahead and separate out my terms. If you did it right, the two like terms are supposed to be the ones in the middle. So the c squared moves down. I'm combining a negative 2 and a negative 4 to end up with negative 6. Sorry, my thing keeps freezing today. So now I've got minus 6c and then plus 8.